Hello. If you're watching this video, it's because you are a teacher that has started the scientific challenge with your school, in particular at 3D the challenge at 3D Good choice. I am Bea from the CESAR team, and I'm going to guide you through the process. And you are now in phase 1, so you will see this at the left part. And what is expected you to do in phase 1? So we give you some information here, and this video is the one that you're watching at the moment. And when you complete phase 1 is when you will fill here and you go to the next phase. So phase 1 is preparation. Here we have the student's guide, where we are going to go through the different steps that we propose you to prepare for the scientific challenge at 3D with your class. You're going to do together with your students. This is the student guide to do that. So let's click here to see what the information, what is information we are giving to you. We give you the scientific challenge. That is what we have already asked to your students is, do you help the scientists to observe the Earth with the Sentinel satellites within the Copernicus program? Are you ready to help us? And we give you the minimum duration, that is 4 hours, for doing everything from preparation to at the end sending us your poster with what your teams, a poster per team of what they have learned. So this is the total amount of time, 240 minutes, the minimum time, but you can take one term doing this activity at different blocks. It's your decision. The student's guide, that is the one that you have here. The quizzes that is going to be executed in phase 4 at the end, after the challenge, to see what they have learned or not. And the web tool that we will use in the phase 3, that is Google Earth. So here you as a teacher has the complete picture of what is going to be used. So here this second document is the teacher guide that we already had it here, but in the PDF format. So you can click here and download it, but we also give it to you here. And as I said, this is the video that you're watching at the moment. So let's explain the colors. Why do we have several colors? The documents or the links for quizzes B and I are the same. What we want to say with this is that this activity has been prepared for primary, for 9 to 11 or 9 to 12 years old, but you can extend it to intermediate level. This is the only thing that means the different colors, but the student guide here and here are the same. Okay, so let's go through then the guide for you to know what we propose you to do in phase 1. You have many activities. We are giving you many activities to prepare with your students, but you can select the ones that you prefer. Also in the teacher's guide, we give you some adventures depending on the activities you have selected. We always recommend you to do activity 1 because it's refreshing concepts that you have already explained to your students in class. They match with the curriculum. So it is good for them to use what they already know, or to refresh it with this or with other material that you want to use for the scientific challenge. So let's go. In the phase 1, what do? We first create the teams. So you, as a teacher, divide your students, or let them to divide themselves in teams of 4 to 6 people, we recommend, but you know the size of your class, so it depends on many things. And these students, within the team, each student has a role. In primary, usually in Spain, what we use is we have the writer, the responsible of the material, the reader, the speaker, and the drawer. That's why we're using the same roles. For elder students in other scientific challenges, the role matches with an activity done by an engineer, a scientist, so depending, we give them some other roles. But here for primary, we give it like this. The student guide is editable. The idea is that you don't need to print it. If you have computer, they may edit in Teams using a computer or as you decide, but it's possible to do that. So they can fill the challenge ID, that in this case is this ID, is the registration ID for your challenge. So in case that at the end you want to give us the information of what they have done, that is not needed, but if you want, we can track who is what group who you are, let's say. We can follow the whole process. And the team number, maybe you are creating teams from 1 to 6, or depending on the number of students again. So for example, I am the team 5. Okay, and I write here, I write there, and I am. Okay, super. Phase 1. So we said that we are going to refresh some concepts that you have already studied in class. For example, the idea with this activity 1 is that students decide what word matches with the description of that word. What else? We have activity 2, how to draw a map. So we propose that they suddenly wake up on any of these 2 places, they decide in which one, and they need to identify whether it is a river, whether it's an island, whether it's a valley, where they are. And we ask them some questions. How to find where you are. So this is to explain them that sometimes we need a view from the top, another view. Why do we need satellites, no? For example, to observe even planes, to know where you are in a wider context. Here we give the students in activity 3 some areas in Spain. You can also use it in your country if you want to get it more familiar to you. And they will identify where are some specific islands or some specific lake, or which is the input or the output river to the lake. So just for them, again, to get familiar with what you already have studied with them in class, most probably about the topographic maps, about the physical maps in this case. Activity 4, where to draw something in our map. We propose here that the students draw their own map, and they draw their own island, for example, and they put a 3 here and another here, and for example a river, whatever, that they draw their own island, and that they measure the distance. Then we also propose them to simulate within the area where they are, the class, at home, whatever, their own island, and measuring in steps, they know the distance between the points that they have put as reference or as icons, no? For example, a 3 and another 3. So they will compare the measurement in the map with the measurement in the area where they are. So they know about scales. And later on, we talk to them that it's important also to have reference points for that. What else? They evaluate themselves, their own map, and again we tell them how important it is to use satellites, for example, the Galileo system at the moment, or Copernicus program. Activity 5, what types of maps are there? So we propose 2 ways to create 3D maps, from 3D maps to 2D maps. One of them is more classic, is if you have some plasticine, and they have their own mountains, like for example here, and they cut the mountains at different heights, and they can plot it to a 2D, no, the topographic map. So they have here the contour lines. Each color represents an altitude. And we propose also another alternative to this, that is using GeoGebra. With GeoGebra, that we are also guiding you, you can draw a mountain and also make the contour lines. You can make a valley and also the contour lines. And this is something that they can do, or if you find a bit tricky, because the way to do that is you editing you have to edit. I give you at the end the answers in the teacher's guide, but you have to edit yourself you have to create yourself. What we have here, I mean, go to here, we have to do this. We have to do X, or you can do it also here, X, 2 plus 4. This major in reality means that you don't need to click major. In reality, it means that you need to put yourself here. But So we have plus, I, then you start to see things now, divided by 4, well, you also can click here, so minus 10, enter, and then you have this, and you can move it yourself around, or if you have a tablet it can be even more fun if you do it yourself. And we give you the procedure to create, as we were saying, mountains, valleys, island, and it can be quite fun for them. Does my island have water, reservoir, or rivers? This is a bit of conscious about how to keep water. A study of climate change with maps. Also, we have some videos from Sentinel, how you can not only measure the altitudes, but also the difference in temperatures and pressures using the contour lines. And Activity 8, Earth exploration by the European Space Agency missions. So we talk about mainly the Copernicus program with the Sentinel missions. What do they do? And at the end we ask them to see whether they have understood what each one of them does. And then, before going to phase 2, we ask them, what have you learned so far? So what is this? We have in all our guides this. You should want to leave? No, stay. Okay, can I open it here? Leave, okay. Ask me to leave. Okay, we want to go to the Kahoot. For primary, we have Kahoots to see whether they have learned what they have understood what they have already done before going to the scientific challenge. So this is taking a bit long. Okay, so at 3D Earth. So you can play as a guest, and you can hear, I say you, but it's your students. All what I'm telling you is something that we propose you to do with your students at your speed, at home, in class. So let's go team mode. Let's go to the team mode, waiting for the teams. So they will use the phone, or at this age most probably they will use tablets, they don't have phones. And we go here to Kahoot application. You can also do it yourself with one computer, and the teachers will reply aloud. So we have here Kahoot, I have here Kahoot, and then I put the game is 9-0. Is 9-0. In this case, be aware that this number is going to change from time to time, but not the link. The link inside is going to work. Enter. Team name, Super CESAR, for example. Okay. For example, ready to join. And you as a teacher will click start when all your students have already filled their names with the teams. So start. You're guiding as a teacher. At 3D Earth. So you have some questions. Quiz. Which is your team? Okay, first of all, again, because this information can be stored so you can track. So my team is, oh no, I have to reply here. I have to reply to the phone or the tablet. I am a student. So I click this one and I start. Okay, next. You, the teacher, click. So we are Super CESAR and we are winning. Okay, super. Next. Quiz. What is the European Space Agency? And in this way, with 7 questions, they have some time. Team talked. So they have some time to answer, and the idea is that they test whether they are prepared or not, or you test whether they are prepared or not to go to the next phase. And if you think that they are prepared, then you come here and say, yes, I have already done the phase 1 for the 3D Earth. I rate the activities. Maybe you don't have done everything. Maybe you have done, for example, GeoGebra, and you have not done the plasticine. So I have done activity 1. We propose always to do 1, 3, 5.2, blah blah. Okay, continue to next step. Please check all your data. You won't be able to revert this. Okay, yes, continue. And then we come to phase 2. And this is another video. Okay, so enjoy phase 1, and we see each other when you finish. Bye.